Okay, in this short video we're going to find the area of a regular pentagon with a radius of 6. And the first thing we're going to do is we're going to remember back to what we did in an equilateral triangle, a square, or a regular hexagon. And that is, we need to know what that angle right there equals. And to do that, we drew all the radii. We know that there's 360 degrees all the way around. We're going to divide that by 5 because there's 5 of those angles. So we'll take 360, we'll divide it by 5, and that answer is 72. We really only want half of that angle. So 72 divided by 2 makes this angle here 36. And if we subtract that from 90, that angle down there becomes 54. So in this problem, if I just pull out that radius apothem triangle, here's the apothem, here's the radius, that was 6, here's half of my side, that's this length right here, I'll call it x. In order for me to find the area of that triangle, I need to get A. And in order for me to get the area of that triangle, I need x. So we're going to find A, and we're going to find x. And we're going to do that using trigonometry, because we only have that choice now. In a square, in an equilateral triangle, in a regular hexagon, we could use special right triangles. I kept using trig because I think it's quicker. So to find A, we got a 54-degree angle. That's opposite hypotenuse. So I would say the sine of 54 is A over 6. So 6 times the sine of 54 is about 4.85. So my apothem is 4.85, which is the same thing as the height. And to get x, I'm going to use cosine. So cosine 54 is x over 6. So we're going 6 cosine 54. That's about 3.53. X is my base. So now the area of that triangle is base 3.53 times the height 4.85 divided by 2. And how many of them triangles do I have? Well, for each one of these triangles I actually have 2. So I take number of sides times 2, so that's 10. So I'm going to multiply all of this by 10. So we're going to take 3.53 times 4.85. We'll divide that by 2, and we'll multiply by 10. And I came up with 85.6 units squared.